Hello everybody and welcome to the round glass review for the Pentax-FA 31mm f1.8 Limited. This lens was developed by Takayuki Ito and Masayuki Murata at Pentax, and then it was produced by Pentax, Hoya, and Ricoh as the company, as the division and intellectual property changed ownership. This lens was made in the iteration reviewed in this video from 2001 to 2021. After 2021, the new design included the latest HD coatings and, according to Ricoh's website, changed the lens formula from 9 elements to 8, dropping the last element in the optical design. So that lens is different and should be expected to perform differently than the lens in this video. Whether on full frame or APS-C, this lens is a jack of all trades that excels at basically everything. There are some focal length limitations, such as you won't be using a single frame to create an expansive landscape with ultra-wide-angle lens coverage, but shy of wanting to do things that this lens physically can't, honestly, this lens is going to do everything you want it to do and do it well. So for your bottom line up front, Pentax forums ranked this as the best standard focal length lens ever made for Pentax systems and the second best ever Pentax system lens after the 77mm FA Limited. This lens absolutely earns that reputation, as everything that we're going to see in this video will show. The focal length and angle of view are 31mm and 69.8 degrees on full frame, 46.5mm and 49.1 degrees on APS-C. The aperture range is 1.8 through 22. The element and group count are 9 and 7. Design type is retrofocus. Filter size 58mm. Closest focus is 30 centimeters, which in the US we call 1 LRDGC, Land Rover Defender Ground Clearance. The focus type is screwdrive autofocus. The native mount is Pentax-K, and the dimensions are 65mm by 68.5mm. This lens weighs 348 grams, which really is quite heavy for a lens of this size. My first tip is that this lens is basically ideal for Pentax users with full-frame, APS-C, and film cameras. This lens can work on any Pentax K-mount camera made from 1975 until today. An old K1000? It works. A brand new K3 monochrome? It works. Anything in between? Yeah, you got it. It works. Related to that, because this lens has an aperture ring and a mechanical aperture coupling, it will work with Pentax K to your mount mirrorless adapters. Standard, macro, tilt shift, and speed booster adapters are all viable options for this lens if you shoot mirrorless. My next tip is that as a 31mm lens, this is a great slightly wide lens on full frame and 35mm film that provides a normal perspective without wide-angle distortion, while also delivering a pretty good depth of field and a field of view reminiscent of those wide-angle lenses. This video will show image samples of all manner of subjects and styles, and I'd argue that any problems with them are not because of this lens. Next up, this lens is contrasty, and even RAW files, which are notoriously flat on most cameras, have good contrast. If you shoot JPEGs and use any kind of in-camera toning like vivid or contrast enhancement as a baseline, don't do it with this lens. Shoot RAW and adjust your contrast in your RAW editor. You probably won't need to adjust it very much. One substantial benefit of this lens's contrast is that it results in colors that reflect the way that I, at least, see the world, and the 31mm focal length delivers a stunning vibrancy to many scenes. And by the way, that stunning contrast and color rendition also means that on film, this lens is going to perform very well, whichever kind of film you're using. My final tip is that this lens is relatively plentiful on the used market, so as an entry to the world of limited lenses, it's a good option. And these also hold their value pretty well, so if you buy one used and don't like it, or just decide you want to sell it for whatever reason, you can almost certainly recoup much or all of your investment. Alright, let's take a look at this lens's Seidel analysis, and we're going to start with this. Here's the image that I use when I do these analyses, and it comes from Lonely Spec, and then I use data from Handprint, as well as a couple of other sources like some Zeiss scholarly articles, and this black image with these white dots is what I photograph to create these analyses. So let's take a look at the actual photos. But before we get to that chart again, this first image is going to show some out of focus lights, and we're going to analyze the out of focus area characteristics in these lights. Because what these do differently than the chart is that they give us some out of focus area over some depth away from the lens, whereas that chart's just flat. So what this photo reveals in the 31mm is some physical vignetting of the image cone by some element of the lens's structure. Wait, what? Okay, so we can see this by scrolling through 4 photos of the lights here, as the aperture stops down and the blurry points change from ovals to amorphous blobs that have part of the aperture shape and part not. So, wait, what's this saying? So if you just have ovals, that could be an indication of vignetting from something physical inside the lens, or it could be an indication of some other optical flaw. We know that something inside of this lens, something round inside of this lens, is causing the vignetting because when you stop down the lens, that oval will start to take on the shape of the aperture. If only part of the oval takes on the shape of the aperture and part of the oval remains rounded, well, what that's telling us is that there is something inside of the lens which is interfering with the aperture's shape, and that is affecting the shape of the light cone. This next analysis is going to go back to that dot chart that I showed you, and it takes a photograph of that dot chart on a flat screen. These dots are white squares on a plain black background. The orange triangle is going to indicate the center direction of the image, so the triangle points towards the center of the frame. As we zoom in, looking at around each corner zoomed in to 100%-ish will show if the lens performs equally around the image area. And with this lens, the answer is yes, it performs uniformly around the image peripheries. Zooming into the center, we can see that this lens exhibits minor lateral chromatic aberration even at the centermost points, which we can tell because the aberrations appear to look like the sliders in the image are out of balance, as opposed to fringing around the contrast interface, which would indicate longitudinal chromatic aberration. The dot to the left of the circle dot is actually the one that was placed at the center of the image sensor for reference. Zooming into the lower left corner, the dot chart reveals some sagittal astigmatism and minor coma smearing. The astigmatism is evidenced by the diagonal blur, and the coma by a blur that points toward or away from the lens's center. Now, combined, these look kind of like the blade end of the pendulum in Poe's The Pit and the Pendulum. The coma here is minimal to the point that it's not even worth discussing, honestly, but as all the tests in this section reveal, the lens does have some astigmatism and a little hint of field curvature that contribute to the manner in which it renders out of focus areas. Another thing that these tests indicate, this lens is highly to near perfectly corrected for spherical aberration. This owes to the aspherical lens element, and a key note here is that the blurry areas do not exhibit onion ring bokeh. This tells us that the aspherical element in this lens was hand ground as opposed to being molded using a lathe-made mold, or perhaps that a mold was used and then hand polished following lathe work to remove the lathe's cutting lines. As a closing note here, lens flaws like this are not detractions unless they ruin images. Lens flaws like this are part of what creates the character in the images that lenses create. Understanding them will help you work with them to create better images. As a note, this video looks at the version of this lens made from 2001 to 2021. The current version, according to Ricoh's website, dropped the last element and changed the glass type and the special elements near the front. Now, one thing that really stands out to me about this lens, the one made until 2021, is how well the aspherical element in it is made. We know it's well made because the lens does not deliver onion ring bokeh in the out-of-focus areas. Now, to me, the onion ring look is a deal breaker. I will never, for any reason, like source points that are delivered with onion rings. Personal preference on that aside, I do think that the out-of-focus characteristics of this lens indicate that the engineers and the builders of this lens, at least back when I bought this lens in 2011, were focused on ensuring that those onion rings didn't occur. If I ever get a chance to try out the new version of this lens, I'll be excited to see if that's still the case. Breathing is noticeable when comparing still images. When racking focus over a 0.7 meter span from near close focus to a bit more than a meter out, breathing becomes negligible. In practical use for video, a short focus throw combined with on-screen action would eliminate the audience's ability to perceive breathing. The aperture is stepped in half-stop increments on the aperture ring. However, on Pentax DSLRs and film SLRs with on-body aperture control in third stops, this lens can be used in third stop increments. The front element is rotating and moves in and out 5 mm, which is a hair more than 16% of the focal length. The focus throw is about 70 degrees. The focus ring is stationary and milled. Under a thumb it feels very nice and would likely be thick enough for a lens focus motor gear. Focus damping is, as I always say with screwdriver autofocus lenses, lackluster. However, on this lens, the internal gearing does not create a slight vibration in the focusing ring, which is nice. The autofocus effect on audio will be noticeable with on-camera audio because the internal gearing makes a whine when focusing. Worse than that, it whines faintly during manual focusing, too, and that means that this lens for video will require off-camera audio sourcing at a point beyond this lens's focusing whine sound. Sharpness is class-leading. You can pixel peep all you want, or simply read the lines per millimeter ratings or the MTF chart, but stop down to f4.5 to f5.6. This lens will outperform very many digital sensors in terms of sharpness and is on par with some of the best ever made lenses. It's going to be hard, if not impossible, to find a lens that matches this one's sharpness in the same price range. Build quality is excellent, with the lens's housing being made of metal and the milling precision being exceptional. Contrast is stunning on both film and digital. RAW files have good contrast out of the camera, which can't be said of very many lenses. Film images pop, and higher contrast films can lose shadow detail, especially if you meter for highlights, because of this lens's ability to deliver out-of-lens contrast. Now, to me, that's one of the hard parts about learning to use this lens, which specifically is learning to use it in a manner that controls the contrast it delivers. Aperture stars are visible by f4 and at their best from f8 to f11. Starting at f16, though they're larger than previous apertures, diffraction scattering causes them to have some blurring between the stars' points. The aperture stars are pleasant and not domineering. Out-of-focus areas are very nice at wider apertures, and at the widest apertures this lens has very pleasing subject isolation, especially in the 3 to 6 foot focus distance. Distortion, even allowing for my slight camera misalignment, is there and in the barrel direction. That said, if you think this barrel distortion is an issue, I'd encourage you to take a second look at the images in this video and let me know if it manifests in a negative way in real-world use. Spoiler alert, it does not. Light loss is present. I did have to correct some exposure issues on these sample images, by the way. I had been trying the Monster adapter at the time with this lens, and wow, what a mistake that was. Anyway, at f1.8 and f2, vignetting can be seen in images in some settings. From f2.8 and smaller, the vignette will almost certainly not be noticeable in practical use, though it doesn't fully recede until f8 when photographing a white screen up close with the focus set at infinity. Flare and ghosting, for me, they're unknowns. I could not get this lens to deliver either. And as I mentioned earlier, I've owned this lens for 12 years. I used it a lot. This lens is beat up. I've never had it flare or ghost once. Balance with cameras is good, and almost regardless of camera size. Admittedly, the K1 feels a bit back-heavy with this lens, but then again, the K1 is a camera that could be used for Olympic weightlifting trials. In the near future, AI will design perfect camera lenses. Designs for any spec, aperture range, and image format with perfect MTF charts will drop out of computer systems every day, or even more often. New designs will drop far more quickly than they can be made and marketed. And they will be perfect, uniform, sterile, and absolutely boring. Imperfection is, after all, the playground of beauty because no more sterile, more boring look exists than perfection. And those perfect future lenses will arrive, sell or not, and disappear faster than 90s rappers could drop new lyrics. Photographic lenses will become transient, temporary, and unexciting. And then, someday, someone will stumble across an old lens for sale, one with a bit of coma mixed with astigmatism in the corners, very slight chromatic aberration in the center, and an image character defined by and made better because of those image flaws. That photographer will fall immediately in love with the look that lens provides, and if that lens they pick up is the 31mm FA Limited, then yes, that love will be well deserved. The 31mm is as close to perfect as, I think, lenses designed by people should go. This lens delivers incredible sharpness stopped down a bit and stunning subject isolation opened up. Across the aperture range, the 31mm creates captivating image rendering that, in the hands of a photographer who can use that image character, will deliver images that can keep viewers' eyes on the scenes. Slight imperfection keeps our attention, the way that asymmetrical freckles across a nose blend into the shapes of high cheeks and flirt with the undersides of eyes, for instance, provides an imperfect avenue for our attention. Photographs do the same thing when a slight swirl in the out-of-focus background directs our view around a scene and eventually toward a sharp, isolated subject that tells a story about a moment. Camera lenses should never be perfect because humans, that is, photographers and viewers, are ourselves imperfect. We will always relate to the imperfect beauty in a near but not quite perfect image, and for creating those, the Pentax 31mm f1.8 Limited is one of the perfect lenses.